Hey, what's going on? In this lesson, we're going to start our discussion on authentication for user authentication and API authentication. We'll talk about some of the differences there. Before we get started, I did want to mention that this is part of a larger series, so you can check out the description for the playlist link, as well as a link to get the notes for this lesson and all of my other videos here. So if you want to follow along both video and notes, then I would highly recommend you check that link out. And finally, wanted to mention that I did complete my fundamentals course. So if you want to get software engineering fundamentals for beginner, intermediate, and advanced topics, I will have that link down below as well. Check out my software engineering fundamentals course if you're looking to build a solid foundation for building software. This course will take you from the very beginning all the way through intermediate and advanced topics with a focus on core computer science concepts and applied software engineering principles that make you a better software engineer. Follow the link to get the first section free. So let's talk about authentication. And I will also talk about authorization. So a very similar topic, but slightly different in concept. So let's just talk about that first. So authentication and authorization. So let's say we have some web page or some resource, but this isn't available for just everybody. We want to know, do you have the permissions to view this content? So what does authentication have to do with this? Authentication is you proving you are who you say you are. So for example, you go to the website, it says, yo dog, you can't visit this page, and it kicks you back to a login page. So you log in, and if you successfully log in, then you are authenticated. But just because you've proved you are who you say you are doesn't necessarily mean you can view this. So then it comes down to authorization. Are you authorized? So we'll look at both of these throughout these lessons. The main thing you need to understand is that difference. Authentication is basically saying, hey, it's me, here's proof. In this case, it's proof because I have the username and password for my account. Then authorization is what you are allowed to do. Do I have access to this page? Are there certain features I have access to and other ones I do not have access to? That's all related to authorization. Now there are two major classifications for authentication that I'm going to talk about. We have user authentication, and then we will also have API authentication, or you can think authentication for services. So let's first take a very quick look at user authentication, and then we'll take a very quick look at API authentication. Then we'll go into more details, but I want you to have an understanding of these categories from the beginning. So for user authentication, that is if you are a user of a web page or some app, and you log in, and this allows you to access all of the hidden data. This is basically how login works for web pages. It's basically a way to identify the user, which would make sense from the name. One of the most common structures for this would be using JSON web tokens, and we'll talk about what that looks like. API authentication is a little bit different. So let's say we're building an app and we need to connect to some other service, and this service exposes an API, but it's not a public API. In order to use it, you have to use an API key. So this API key kind of acts like a password to make an API request. So you're not going to be able to get that data back unless you provide the appropriate API key. And then what is this over here? Most likely this is going to be some backend of an app. And then this API is likely some third-party thing you're using. So maybe that's for maps, or maybe it is for some AI, LLM integration, or really any other app out there that exposes an API. You could put there. Now, in many situations, you're going to be on this side of things. You're going to be building services that use APIs, but there are situations when you're going to be building this side as well. So let's say you built some social network, and then you release an API, and then other apps can consume your API. You will need to have a strong understanding on API authentication, because you're going to want to make sure that these other services are authenticated and they're able to use your API. Otherwise, you're just going to have a public API, which you can do, but in many situations, you don't want to do that. You actually want to scope things to just authenticated API users. It's also step one for controlling what they can and cannot access, and things like rate limiting by user. So if you're wanting to make an API service layer, this is going to be very, very important. And in that situation, you're going to be on this side of the communication. You'll want to be familiar with both of those sides though. So consuming APIs, using an API key, and building APIs where users use an API key. This one is definitely more simple because you're most likely just going to be working with a front end that makes a request to some back end. And we need to understand how that front end back end flow works. So now that we understand those two categories, let's take a deeper look at user authentication. And let's say we have some resource that we can delete. So we'll say delete is the method for the request. And then this will be something like /comments. So we have the full list of comments and the user wants to delete one of them. This is something where we are still working with an API. And this is a very important clarification I want to show. Just because we're using the user authentication and not API authentication doesn't mean we're not going to be working with an API. It's just that the purpose of the user authentication is to authenticate user actions. So this is basically how the flow is going to look. We'll have an end user. He's really happy because our app is so good. He's going to interact with the app from maybe his mobile phone. And on there, there is a delete button. When you hit that delete button, it's going to make a request to the back end. So that's the back end. This is the front end. We'll need to make sure that that request is valid based off of the token they provide. And if it is, the back end can then issue a delete to the database. But we only want to be able to do this if this user is logged in and they are authorized to do that action. So that's the overall flow. It's dealing with what the user can do. And in code, basically what this is going to look like is going to be a protected route. So some function that handles the request, but it's protected, requiring a correct token saying that they are able to do this action. So that's the flow. Let's talk about what that actually looks like. First, the user comes to the page, they log in. That will give them a token. And then this token will then be used with any of the future requests, such as a delete, anything that requires the token. So anything protected, that token will then say, hey, I'm allowed to do this action, so you should now do that for me. So what happens if the user tries to do something and they haven't logged in? So let's say we try to delete something. We can program this to redirect because the backend will give some form of auth error, basically saying, hey, you need to log in. So this will allow us to redirect on the front end to a login page. So the user is now on the login page. They put in their username and password. This will check the backend to make sure that the username and password is correct and exists in the database. And in exchange, it will give back a token. And I'm going to write JWT here. We haven't talked about the JWT structure yet, but it's just a token that this user will keep. And the token basically says, hey, I logged in at some point. So we know that it's a valid user. And inside of that token, we can also have any kind of permissions or authorization stuff. Once they have that token, they can then go back and retry that initial thing that they were not allowed to do. So this is exactly what happens when you go to a web page. Maybe you step away for a couple of hours and you come back. The web page is still loaded there. So you do something that would require you to be logged in. maybe you delete something, but your login has expired, so it redirects you to a login page. You log in, and then it may re-execute that action or ask you again to do that action. That's the exact flow of what's going on behind the scenes. Also, that says login. I was like, looked like a B. I couldn't figure out what it said. So here's how a token works. So I mentioned we go through a login page, and if we get the credentials correct, the server will issue a token. So here we have the backend server, and this backend will sign the token. And this gets a bit into cryptography, but basically this digital signature here is what will allow us to verify the token in the future. So when we send the token back to the user, and then the user makes future requests, this gets sent to the backend, and the backend can verify the token authenticity. If the client were to tamper with the token, try to adjust their permissions or anything like that, it's going to invalidate the token because the client is not able to sign, because to sign, you have to have a signing key. And this signing key is a secret value that only the server has. So when you get into user auth, you will often have that secret key. That's very important to protect because it is used for signing these tokens. The signing is important because it allows the backend to later verify the tokens that are sent from the client. If the client were to modify the token, this would produce a different signature because the client does not have the signing key. It never leaves the server. So the server would be able to identify that this is a phony token. So what is a token and what does it actually look like? Well, if you look at a token, it's just going to look like a random sequence of characters and numbers. So behind that is encoded information. So let's take a look at it in more detail. So let's take a look at JWTs or JSON Web Tokens. I'm going to do a dedicated video on JSON Web Tokens, so this is a very light intro, but it's basically just going to look like random numbers and letters separated by dots, and they're going to be a lot more. I just don't have much space, so maybe I'll put like 3 dots here, and then a dot, and then another section of characters, and then another dot, and then another section of characters. So we basically have 3 sections here. I wrote that pretty bad, but that's okay. This one is called the header. This one is the payload. And this is the signature. The way you can imagine the signature being made is something like this, where we invoke the signing, but we use the existing information, and then we use the signing key that only the server has. So the fact that we are embedding this information into the signature, changing this information will change the actual signature value here. That's an important component if you want to understand how JWTs work, because that's what allows the prevention of tinkering with these values on the client. The client shouldn't be able to touch these and get the server to trust that token, and it's not going to be possible because if they mess with this data, that is part of the signature, which requires the signing key. So we don't have that signing key, we would have to use a different key, and the token would be invalid. Now, because the server is the one creating these tokens and validating them, the server can put whatever it wants in this payload. And that could be even something like if that user is an admin or what authorization things they have. So this payload, maybe it contains their user ID, which we could then use to look up that user in a database. But we could also just embed any other information that could be useful in the payload, such as if this user is an admin or any other kinds of privilege attributes. So in this situation, all of the authorization is self-contained in this token, and we don't even have to make a database request. And the way this works is if this was changed, Let's say the user wanted to tinker with this token. They changed admin to true. Well, this would force the token to be invalid. Again, just going back to the fact that the client does not have the signing key, so we're not able to make any changes to the token that the server would then accept. So those permissions are pretty much baked into the token. It's the full access pass. You don't want that token to be taken by a malicious user because they could act on behalf of another user. Whatever token they have, it's full access. It's as if the user logged in themselves. And it's self-contained, so this is stateless. So that means if we had an API endpoint, we can think of that API endpoint in isolation. It doesn't need to access a database or do any extra stuff. All it needs is the request and a token. And that's enough to give permissions to do things. Now let's take a look at API keys. Similar ideas, but there are some key differences. So an API key will allow the user in this situation, which is most likely going to be some other service. So it will allow the service to do things, but most of the times it's not stateless. So it's a different structure than a JWT. And you can think of it sort of just like a password. You make an API request, you include the API key, the backend will take the key, can check against the database to see any kinds of permissions. If we're good to go, we can send the data back to the user, or the service in this case. So what this could look like is you might sign up for some API, and in here you might have multiple keys. So you can imagine logging in to your account for the platform. You can go to your API keys, it lists them out. Every single one of these keys can be seen as separate logins effectively. And they might have different permissions, separate spend tracking, or separate rate limiting. These things could be set by service B, or you could set them potentially. So when you create that API key, you could say, hey, here's the permissions I want this key to have. And we could potentially even limit that key so it doesn't spend more than this many API credits or make this many requests. So in that situation, you could just use a single one of these API keys for an application, and you could use these other ones for something else. So instead of thinking of the API key as just full access to the API, you're usually going to be able to limit those capabilities. Now what I'm describing here is a pretty common structure, but you could see variations. For example, you could probably make these API keys be signed and not require database access. Or maybe you get a key per user instead of a user being able to create multiple keys. There are a lot of variations, so what I would recommend is just taking a look at some of the different API platforms out there. Maybe take a look at some popular social media networks, look at some payment processors. So maybe look at Facebook and Stripe and see how they run their APIs. Ultimately, both user auth and API auth are trying to achieve the same thing, just slightly different in approach. So this is how I decided to group them, but you might see slight variations or some crossover in concepts. So for example, with JWTs and user auth, you could still check a database if you needed to keep track of invalid keys or any other things related to specific keys. You can store that all in a database. So it's not the case that if you're using JWTs, you never use a database. Now, one big difference between JSON web tokens and other tokens is that JWTs can be decoded, but other keys are typically opaque. So what that means is if you have an API key, it's going to look like a bunch of random characters. Those characters, you're not going to be able to interpret those in some way unless they sometimes will put something at the beginning. So it might have like the service and then like a hyphen and then all the random characters. But the main point here is that you're not going to have information in that token that you could see. Whereas with the JSON Web Token, you can decode this on the client side even, not just server side, and see the payload. So you might see something like this. And obviously I'm going to be an admin. This is just encoded, and encoding is different than encrypted. The information is still retrievable. It's just not immediately visible unless you decode that information. So if you want to know more about that, you can read about base64 encoding. Whereas API keys, you're not going to be able to just decode those and read the information. And it's probably more likely that the API platform will access the database to get additional information about your permissions for that API key, or to check if the API key is valid, since you're often given the capability to immediately invalidate tokens. We basically need a way to know if a token is valid, and for that you'll often have a database for invalid API keys. Now let's talk about how API keys and JSON Web Tokens are actually passed. They are typically included in the web request in an authorization header. And then the next thing here is the authorization scheme, which typically is just going to be bearer, and then the actual key. So let's put some random numbers here. So this is what that header would look like with that request. If you're doing it from an application, you can often include headers with your request. So you'll need to understand the syntax to include an authorization header, which should be pretty simple, just look it up. Or if you're doing it from some other client, such as Postman, there's probably some way to include any authorization headers from the menu or wherever it may be. So whatever tool you're using, maybe it's Encode, maybe it's some tool, or maybe you're making just like curl requests or whatever it may be, you need to include this as a header. Typically it's going to be with the bearer scheme authorization header, but you might see custom stuff. So you might see something like X API key. This is a custom header. So the client can include arbitrary headers, and then the server would just need to know to check for that. So you may see that as well, but I would say this structure is the most common. So that's your introduction to authentication with JSON Web Tokens and API keys. We have a lot more topics for this, so stay tuned. First thing you should know is a better understanding of JSON Web Tokens, because that will deal with access tokens and refresh tokens, so you'll want to understand that. You should also understand social logins and OAuth. There are topics like throttling and rate limiting, and a variety of other things dealing with APIs and user logins, so stay tuned for the upcoming content. If you have any questions or different topics you'd like to see me cover, leave a comment below. Be sure to check out the notes, the courses, and anything else down in the description, and I will see you in the next lesson. Thank you.